Okay. Good morning. We'll go ahead with this topic. Okay, that is your biomass. Okay, so we were seeing a different technique. Okay, different technique and whatever it has been there to convert this biogas energy into the usable form. Okay, so we have seen direct conversion. We have seen thermochemical process. We are into your uh, biochemical process. Okay, so in this we use bacteria or your yeast, okay, to break down of biomass energy. It is generally in the form of glucose and other uh, com, uh, organic compounds. Okay, that's been break. Okay? So now this fermentation is process is not new. Okay, it isn't a new idea. This process is being used in a lot of way, in lot of process. Okay, if you could see uh, this fermentation process. Okay, it is generally a breakdown of your uh, sugar into different chemicals. Okay, it is being useful to break down into your other components. Okay, uh, some bacteria, I don't that bacterial name, but it is being used the formation of alcohols. It is being used uh, to formulate the cheese what we used to eat. Okay, that Swiss cheese. Okay, so these processes are not a new thing. It's been adapted in a lot of variant way. Okay, and it is applied for different segment, and also it provides you uh, residue. Okay, the usable form, that is a gas outlet, and also the residue what is being used. Okay, we can use fertilizers are the residue that is being done for agriculture and forest waste. Okay, so that is being used in that particular manner. Okay, so what is a fermentation is okay. Fermentation is an anaerobic process. Okay, that breaks down the glucose into uh, uh, or the it is a process which break down your sugar. Okay, in uh, uh, into any different organic materials. Okay, you could call organic materials. Okay, so it is generally a series of chemical reactions. Okay, that converts your sugar into mainly in alcohol and acids. Okay, this is one of the thing. So in this, yeast or any kind of bacteria are added to the biomass material. Okay, which feed on sugars to produce ethanol and carbon dioxide. Okay, now then these ethanols are distilled and dehydrated to obtain a higher concentration of alcohol. Okay, or to achieve the required purity for the usage of automotive fuels. Okay, now then there is a residue part. Okay, what we call the solid residue that is being left from the this fermentation process can also be used as fertilizers, or also be used as a cattle feeds. Okay, in case of the sugar cane. Okay, the basis what is being left can be used for fuel. Okay, for fuel as your for bio boilers. Okay, for boilers we can use as a fuel for boilers. Okay, or for any gasification part also. Okay, that is being done in anaerobic thing. Okay, now you could see over here, okay, that is your anaerobic digestion. Okay, what is the anaerobic digestion? It is a biochemical degradation process, okay, that converts complex materials such as animal manure into methane and other byproducts. Okay, so it is for like animal manures. Okay, as I talked just about sugar cane. Okay, for that purpose, if you how alcohol is being made. Okay, if you are taking the sugar canes, okay, the breakdown of that sugar, it has been done in carbon dioxide and alcohol, okay, and the acids and the solid residue what is been left, it can be used as a fertilizers or the cattle feeds, okay, or as a burning for the boilers. Okay, this can be used. Okay, same if converts this complex organic material such as animal manure into methane and other byproducts. Okay, this methane could be used as a source. Okay, now, so what is your anaerobic digester? Okay, this process is called your anaerobic digestion. So this is your anaerobic digestion. Okay, so this digester, okay, is a device that promote the decomposition of manure or digestion of the organics in the manure to simple organics and gases, biogases product. So these biogases products are being stored in the form of material. Okay, now biogas is formed by the activity of anaerobic bacteria. Now, in this process, in this digester, you use bacteria, special kind of bacteria, okay, which helps in breaking down that organic component into the simple organic uh, materials. Okay, now the biogas is formed by the activity of anaerobic bacteria. The microbial growth and biogas production is very slow at ambient temperature. Okay, now, so these bacteria occur naturally in organic environments. Okay, where oxygen is very limited. Okay, so this biogas is comprised of 60% of methane, 40% of carbon dioxide, and very 0 to 0.4 percent of hydrogen sulfide. Okay, that it is totally a breakdown of animal manures. Okay, the animal residues, be it human or be it animals. Okay, both. Okay? So these manure is regularly put into the digester, and after which the microbes break down the manure into biogas and the digested solids. Okay, this digested manure then is decomposed and it is stored in a storage structure. Okay, now that could also be used in some of the kind of man fertilizers as well. Okay, to the different plants and different segment. Okay, the solid residues. Now, see, the first methane digester plant was built at a leper colony in the Bombay, India. Okay, this biogas is very corrosive to equipment and requires frequent oil changes in the engine generator set to prevent mechanical failure. Okay, so you could highlight this point and you could remember that biogas is very corrosive to the equipment and requires frequent oil changes in the engine generator, okay, set to prevent mechanical failure. So the heating value of biogas is about 60% of natural gas and about 1 by 4 of this propane. So this is a heating value. Means if you want to change in the replacement of the other present natural gases of propane, so in that it's a comparative value. Now, because of low energy content, okay, it's only 60%, so low energy content, and it is corrosive nature of biogas, storage of biogas is not practical. Okay, now there are two major types of biogas design promoted in India, that is a floating drum and fixed dome. Okay, so we could see this figure and you could get. Okay, see, this is a floating gas holder drum design, a conventional Indian design. which this one is your floating gas holder drum. Okay, this particular is floating, is not fixed as such. Okay, and another is your fixed dome. Okay, this is a fixed dome. I see, you could see a fixed dome kind of structure is there. Okay, so we called a fixed dome type. Okay. Okay, now, so the floating drum is an old design, okay, with a solid milled steel, okay, ferro cement of fiberglass drum, okay, which floats along the central guide frame and act as a storage reservoir for the biogas produced. Okay, the fixed dome design is of Chinese origin and has dome structure made of cement and bricks. Okay, so you have seen a dome in lot of mosques and temples. The same kind of structure is being made, and it is cemented. Okay, and it is a fixed structure. So it is a low cost alternative to the floating drum, but requires high masonry skills, and it's prone to cracks and gas leakage. Yes, it is fixed. It is a very prone to the gas leakages. Okay, cracks and gas leakages. Now, family biogas plant come in different size depending on the availability of the dung and the quantity of biogas required for cooking. Now, the average size of the family is 5 to 6%, and thus biogas plant capacity is 2 to 3 meter is adequate. The biomass requirement is estimated to be 200 liters for a family. So it is a uh, average data. Okay, whenever you are calculating or whenever you design, you could use this requirement. Okay, if you want to have, or you have to allocate your biogas production. Okay, and we have to count out the family. Okay, so this much of energy would be required. What will be the plant capacity? So this is your 2 to 3 meter is adequate. Okay, for a 5 to 6%. So this is you can count. We'll discuss about case studies. So in that, we'll see how it is being used and why it is being stated so. Okay. Now, comparison between your fixed dome and floating drum. Okay, so you could see digester. First part is your digester and glass holder masonry or concrete structure. It is based on the structure. Okay, digester, masonry, and gas holder, mild steel and fiberglass. So the material that is being used over here is your mild steel or fiberglass. It is your concrete structure or masonry or concrete structure. So this is one segment. Okay, now second, it requires high scale for creating that drones, and it is very low scale for fabricating skill is required. Very low skills are required. Low reliability due to high construction failure in this, and high reliability as gas holder prefabricated. Okay, it can be prefabricated. Now, variable gas pressure, constant gas pressure. A digester could be inside the ground. Okay, it could be inside the ground or it could be outside the ground. Okay, requires space above ground for 3 tanks, inlet, digester, and outlet. Okay, now cost, low cost. Okay, that is 2 meter cube will be costing you 5,000, and a low cost for this is around 8,000. So comparatively it's okay. Okay, we have seen this okay, this is inlet and this is your outlet. This is your gas storage. Okay, this gas outlet part. Okay, and this only digester happens. This we have inlet pipe. This is a drum which could be below the ground. Okay, above this is a gas storage segment. Okay. Okay, now case studies. Okay, first we'll go with this part, uses of biogas. Okay, so where could be it is be used? Okay, biogas can be directly used for cooking by supplying the gas through pipes to household. Okay, from the plant. This bio the from the biomass energy, all the biomass energy could be converted into biogas, and that biogas could be utilized as cooking, okay, for the cooking purpose, rightly as a cooking person, though it is a 60% less efficient, it has low heating value, even though we could use, okay. Now, as it release very lesser heat as well as lesser pollutants because it is already burnt, okay. Now, biogas has been effectively used as a fuel in industrial high compression spark ignition engines, okay, to generate electricity. An induction generator can be used and is the simplest to interface to the electrical grid, okay. Induction generation drive uh, uh, okay, induction generators derive their voltage, phase, and frequency from the utility and cannot be used by standby power. Okay, that segment is means you could conclude that you could use induction generators, okay, to produce electricity from this uh, uh, biogases. Okay, now biogas can also be used in a hot water heater if hydrogen sulfide is removed from the gases. Okay, this is also one of the segment. Okay, now we'll look on the case studies. Okay, these are the case studies are taken from Indian. Okay, few of one is from Karnataka, one is from your West Bengal. Okay, one plant is been taken from your West Bengal. Okay. Okay. And this pure village is taken from, I think so, it is from Varanasi or something in your Uttar Pradesh. Okay, this is one of the village uh, uh, present in Uttar Pradesh. Okay. Now this is being used for electricity purposes, so we could account and we could see how it is being, okay. So in India, biogas option is considered largely as a cooking fuel. Yes. So whenever you are going to count the number of cattle have been, okay, cattle have been there. Okay, daily agriculture residues are there, or forest residues are there, okay, in a particular village. Like I will take a concept for this, that is your pure village, okay, that is in there in Varanasi, Uttar Pradesh. Okay, in that particular segment, if you are calculating, if you are targeting to generate electricity to fulfill a small amount of load of that village, okay. So you would never consume or assume the 100% of the biomass that is being collected. Okay, there would be never that. So as we know, that is being used as a cooking fuel. Okay, the wood chips, the agriculture, or sorry, the agriculture residues. Okay, and even the cow dungs are being formed or dry cakes, and it is being used uh, for cooking purposes. So whenever we estimate that this is the land area, okay, this is the agriculture practices is done in this particular land, this is the forest covered at that particular land, this is the number of cattle present over there. So we use only 60/40 or 70/30 ratio. Okay, there's 40 and 30% are being accounted as a that many of the agriculture, sorry, the villagers are using raw dry materials, okay, to for cooking purposes. Okay, so we assume that particular point because 100% efficiency will not be uh, uh, derived, okay, from that particular line, okay, because that is being practices from ancient times. Okay, uh, these villagers used to cook on on these resources. They are dependent on these resources, so we never count that. Okay, so whenever you are calculating or you are doing such stuff, you do not account these stuff in that. Okay, now, so in India, biogas options is considered as largely uh, as a cooking fuel. Okay, now need for considering decentralized electricity options are, and the potential of biogases is analyzed. Okay, now a field demonstration program was implemented in a pure village in, okay, this is pure village in south. So this also a village, pure village is there in Varanasi. I don't know how they have taken, okay, this is, they have taken it for South India, but I know one pure village is there in Varanasi. Okay, you could, I know about this place, but this is done. Okay, one more same name village is there in South India. Okay, village in South India. Okay, to use cattle dung in a community biogas plant to generate electricity for services such as pumping, drinking water, home lighting. Okay, so this is the load. Okay, the load what has they derived. Okay, that is your this community, okay, to use cattle dung. Okay, only cattle dung. Okay, in a community biogas plant to generate electricity services such as pumping, drinking water, home lighting. Okay, so these are the loads. Okay, this is a pumping, drinking water, and home lighting. This is the particular load that is being derived to this biogas plant. Okay, let's see ahead. Okay, so the existing community biogas plant system as it's not pure, it's a pura. That's why it got confused. Over here it is written pura. It is written over here pure. Okay, fine. No issues. We have to consider only about the this part. Okay, it's a pura village. That's why I got confused. Okay, that is a pure village, and this is a pura village. Okay, so you could see, okay, we have cattle shed. Okay, from that dung we can use. Okay, that is a house. Okay, where sludge has been prepared. The residues could be used for agriculture fields. Okay, that is also one of the segment. Okay, so these uh, uh, this cattle's residues are being used in biogas plant. Okay, which it's been the generation of biogas has been done, and that biogas being utilized as your engine set. Okay, that is your heat exchanger generator to produce electricity. Okay, to generate electricity, and then again it is being sent to pump set. Okay, and it generate pump the water. Okay, pump water to the houses or pump this public taps. Okay, see over here, the this is your house. Cow dung is being cattle shed is there, dung is being given to the house. They use few of the okay, cattle is being taken care from this house. Means this is your target people. Okay, or loads. Okay, you account as load. This is your resources. Okay, which produce you the resources. Okay, now over here this sludge, okay, that is the residue of this part, some of the dung and all been used to the field as well. So